Hey, good morning, everyone. My name is Daniel Lumi. I'm a senior product manager at Offchain Labs, working on Arbitrum core protocol. So today I was going to give a speech on a slightly different topic, but we have a week of actually really exciting announcements, so I'll drop some alpha here for you guys for Arbitrum. So we have a plan to ZKify Arbitrum chains, or at least to provide the option for it. So first, a little bit of Offchain Labs. We are the core developer behind Arbitrum. Arbitrum is the largest layer 2 blockchain. We have over 14 billion TVL with over 1,000 applications deployed on it today. We're also trusted by a lot of large partners. So for example, if you saw Robinhood announcement yesterday, they're building a tokenized asset platform with Arbitrum technology. We also have securitized in Athena, backed by BlackRock, chose Arbitrum technology. We have Hyperliquid, we have GMX, and a bunch of big giants basically trusting the technology. So today we'll be talking about our plans to ZKify Arbitrum, or give the option for Arbitrum chains to choose ZK as a proving mechanism. So today we use fraud proofs, and fraud proofs are this mathematical cryptographic game where basically you can prove that something happened correctly by running what's called a fraud proof bisection game. And the fraud proof paper was actually written by our chief science officer, who afterwards became the chief advisor, technology advisor to President Obama, Stephen, who's a Princeton professor, and one of their college grads. And this was actually before layer 2s even existed, or the concept of layer 2s on Ethereum. And the technology then later happened to perfectly fit for blockchains. So it was the first L2 out there that had a decentralized proving mechanism. And it's very battle tested. There's never been any bugs with it. It is fully decentralized. The other nice thing about fraud proofs is it's the cheapest proving mechanism for layer 2 blockchains, because basically you don't need to run this proving mechanism ever unless there's one, like basically if the sequencer lies, any honest node in the world can dispute that transaction. So it's a one of n security assumption, which is amazing. And if they dispute it, then you run the game. So you never have to actually pay for the proving cost until a dispute happens, which for Arbitrum 1 has never happened, except in the POW fork, it actually did, and it worked just fine. The other nice thing about fraud proofs is, again, because you're not proving, you can have basically unlimited throughput, right? So Converge, the securitized chain, will have 1 gig of gas on mainnet, and they never have to pay for that proving cost. We will also be building multi-prover support. I'll come back to that. Basically, it won't just be fraud proofs. You'll also have TE and ZK behind it. The other thing that you get with Arbitrum chains is you can have private data for enterprise use cases, or you can just have off-chain data instead of posting it to Ethereum using a data availability committee through AnyTrust or a third-party DA like Celestia or Eigen. There are always trade-offs in technologies, right? And every one of these proving choices will have their own trade-offs, and you have to be able to choose for your product needs what fits it best. So one of the trade-offs in fraud proofs is you have finality as soon as you post the data on L1, but you can't settle the chain until 7 days. It's an arbitrary number that was chosen, but 7 days later is there to basically protect someone from censoring the L1 and then stopping the fraud proof bisection game from happening, right? So you need 7 days buffer so that someone can censor Ethereum. You do also need bonds. So again, because we're protecting against L1, you need a bond to be able to dispute the transactions, and those can be quite high because it costs a lot to censor a rollup, or there's a lot that you could steal, right? Also with optimiums, you have some trade-offs in a centralized setting, where if you have off-chain data and that one centralized data availability provider doesn't provide the data, there's basically a trade-off there. So we're developing 2 new proving mechanisms for chains to choose from. We use a generalized Risc V ZK VM to basically prove Arbitrum state transition function. So the first option we'll give for chains is we call it ZK prove all, right? And this is sort of your typical ZK chain, where you post every single batch on L1, you make a proof, and then you verify it, and that's when the chain can settle. So your typical ZK rollup. And the nice thing about this is you have very fast settlement, right? As soon as the ZK proof is on chain, you settle, right? Again, we will develop this with multi-prover, TE attestations for every block on top of the ZK proof. And if someone doesn't provide a ZK proof in time, it falls back to fraud proof. So it's actually, it'll be one of the first, or probably the first multi-prover setup. So you'll have 3 layers of security. And the normal ZK chains also provide a slightly more trustless version of off-chain data, where even if the centralized sequencer withholds the data, you can't move the state without a ZK proof. The trade-off in ZK, and I'm a ZK person, right? That's my background, is it is more expensive, right? So you do have to pay for proving constantly, and proofs are not cheap, even with they've gotten cheaper and cheaper very quickly, but if you're really proving something like hundreds of megabytes or a gigagas, which gaming chains or enterprise chains need, that's gonna get expensive. It's gonna be in the millions to hundreds of millions per chain, right? So maybe that doesn't fit your application. Maybe that's only for the most secure. It's important to be secure, that use case, right? There is also no ZKL2 that has decentralized proving. So how to implement that is still an open design question. Like we know how to do it, but it's never been tested. So for decentralized proving, that'll take a little bit of time for every chain. The third option that we're providing, and this is one that we're excited for, is called a hybrid ZK proving mechanism, right? And this kind of takes the best parts of Bold, which is our fraud-proof bisection game, and ZK. So in the same way as Bold, every time that you post a state on L1, it'll be considered valid until someone disputes the transaction. But now instead of going into a fraud-proof bisection game, you'll just provide a ZK proof and the chain settles. So the nice thing about hybrid ZK compared to a normal ZK chain is it's way cheaper. Again, you never have to run those provers until someone disputes a transaction. So you can save hundreds of millions of dollars that you put into your pocket or into your ecosystem. And you only need to provide those proofs on demand, right? And this does allow for faster settlement too. So you can choose to close the chain early. Whenever you send a ZK proof, basically you close the state of the chain. You also get lower bonds compared to Bold because basically instead of protecting against multiple rounds of grieving attacks, you just protect against the one round when someone posts ZK proof. This is similar to, again, fraud proofs. You can have way more throughput. You can have a gigagas. This is, it's up to Converge to choose what proving mechanism they have, but you can have a gigagas on mainnet. You can support these real-life applications, real-life games, real-life DeFi or banks, and not have to pay for that. Again, we will tier this with multi-provers, where, again, TE attestations, then ZK fall back to fraud proofs if no one provides a proof. And with this, again, similar to Bold, you can have private data for enterprise use cases or off-chain DA. So the trade-offs in this version is, again, it could be up to 7 days for settling. But that's up to you to choose how frequently you want to settle. But that's the sort of end time. We do have solutions, by the way, for this settlement, where if you can use intents through solvers that completely remove the cost from the users or the chains. You just have these big actors in between that market makers, they're really used to this, right? The cost of basically the risk of a chain settling is basically none after someone posts the transaction. So it's really, really cheap and you can bypass the settlement. That's why it's not called finality, it's called settlement, right? And again, with this version, you still do have that same data assumption compared to the same, to the ZK-proof off-chain data version. And so our model for Arbitrum chains is your chain, your rules. You can choose the options that best fit your product. We want to give you that ability. If it's a custom token, if you want to build that chain on Base as an L3 or on Solana or on Bitcoin or in Ethereum, Like we want to help provide the tools for that. You can choose your proving mechanism that fits the best, whether that's a ZK chain that needs ultimate security, like not really even security, but faster settlement, or you want one of these other options. They're all gonna have a multi-prover, they're all secure, and you just choose the options that you want for your chain. You can also choose your language. Like you don't just have to write in Solidity. You can write in C or Rust because we have a multi-VM. We run both EVM and WASM on these chains. The other nice thing about what we're doing with this proving mechanism choices is, again, because we have that multi-prover, this is actually one of the qualifications that you have for stage 2 rollups, if you know what that, like if you've heard about the stages of rollups. This is, you have to have this in order to become a stage 2. It just means that you have a more and more secure, getting closer to L1 level security. And again, for these options like the hybrid ZK, it's going to be decentralized ZK proving from day one. It fully supports it. It can be the first, like if you want to build a chain, you can be the first decentralized ZK proved chain on mainnet. And there's one other part of that basically where you have to postpone DAO updates to 30 days, which we can't do. We're already further on that than most. Thank you, that's it. We are hiring rapidly. Offchain Labs is a big team and we're well funded, so if you're interested in joining, please feel free to scan that. And you can follow me on X. I still don't like saying X. Twitter. You can follow me on Twitter.
Awesome. We're going to open it up for questions here. So if you have a question, just raise your hand, and I will come to you with the mic.
Thanks for the talk. I think the Chroma took the similar approach about like hybriding GK to the ops into rollups. How does it different other than the ZK proving TE part?
I'm not sure what Chroma did exactly, like how they chose to implement this. So I can't really answer to that specifically, unfortunately.
Thank you. You mentioned that the Orbit chains will run multi-VM, both EVM and WASM. What's the reasoning behind that?
Yeah, so we have something called Stylus, and it's just a product name for this. The idea is you can, again, run on the same server. You can run both EVM and WASM. The reason why we do that is, first of all, it enables people to write things in Rust, which is very important for these enterprise chains. Like we have 16 million Rust devs in the world. We have 20,000 Solidity devs. Same with 16 million CN Solidity Rust devs. So it allows enterprises or existing Web 2 people to come in and deploy apps. The other nice thing about the WASM implementation, which enables this, is it's substantially more efficient at execution. Like not even close. So things like matrix multiplication, which is very common in cryptography, is literally 100 times cheaper. Right? A lot of other operations are about 10 to 100 times for anything execution related. So basically what that means is you can have 10 to 100 times more throughput on your chain, but it also allows you to have 10 to 100 times cheaper transactions. So like for example, Renegade, which is this privacy protocol built on Arbitrum, they built their entire ZK verification side inside of Stylus, so they can verify proofs substantially cheaper on chain, and they post a lot of proofs. So for you can build basically very, very expensive operations from your application in that, and then just call from it from EVM. It's fully atomically composable.
Hi, this may be another one you can't answer. I'm wondering about product market fit. So I run RPCs, and what I see just as a node runner is we have maybe, I think, 2 chains built on the Arbitrum stack and easily 15 on the OP stack. What's happening with product market fit?
So that one, I mean, if you saw, again, Robinhood chose the Arbitrum stack, so did BlackRock Converge. We have a lot more coming. Stay tuned this week also. It'll be an exciting week. There has become a shift, right? Like Web3 is a weird space. My old boss when I was at ZK Sync said this, and I love the way he said it. It's like Web3, the only place where I pay people to use my product. OP Stack was willing to give out a lot of muha, like in the hundreds of millions just for base. It was 400 million just for base, right? So Arbitrum wants to have longer term sustainability. So we're doing this in a long-term fashion where we can grow. I think you'll see, like, we had a RAS provider that told me of, like, it used to be basically 70% would ask for OP Stack, 30% Arbitrum Orbit. And he said now it's flop. Now it's 80% ask for Orbit and 20% for OP Stack. So it's you know, it's competition, but I think you'll see a lot of really exciting, like, real PMF companies choosing Arbitrum Stack. Cool. Thanks so much, guys.
Awesome. Thank you so much today. Appreciate it.